Well, hello everyone, and welcome back to Adrian's Digital Basement 2. On today's video, we're going to take a look at this CGA card again. This was the one I recently fixed that had all that corrosion on it. If you haven't seen that video yet, I'll put a link in the description below. You can check that out first. But this card was really in bad shape, and you know what? After cleaning up all the corrosion, it just freaking worked. So I talked about it briefly in the last video that one of the funny things about the IBM CGA card is when you scroll in DOS, there's actually a flicker. That's completely normal, and what I want to do in this video is see about modifying this card to kind of, well, take away that flicker and maybe do some other fun stuff. So let's talk about first why it even flickers, and then we'll see about how we can mod it to take away the flicker. So with this original CGA card, when IBM designed it in 1981, they actually had to compromise in a certain way, where when you're displaying 80-column text, which of course is one of the normal modes of operation for the card, the DRAM on the card, which is right here, 16 kilobytes, is used to refresh the entire screen, but it has some contention while in 80 columns mode with the CPU accessing the memory. The 6845, which is this IC right here, is what's responsible for essentially displaying the contents of RAM to the video output. And this card is running at a 60 Hertz refresh rate, so 60 times a second, it's actually reading through the entire RAM, well, the part of the RAM that's displayed on screen, and then using the character ROM right here is converting that to letters on your screen, and there's part of the RAM that's used for the attributes, for that color or blinking, things like that. And that all happens constantly, 60 times a second, no matter what you're doing on the computer. There's no interaction from the CPU when it comes to displaying the video buffer on the RGB output. Now the problem happens in 80 columns mode. I guess there's just not enough bandwidth with the chips on this thing. So when the CPU goes to read or write from the video memory, which is mapped directly into the address space of the 8088, that access to the RAM causes interference while the CRTC, this chip right here, is refreshing the screen. So as it's drawing the text screen, any reading or writing to the memory is going to cause snow. And that's the CGA snow you probably heard a lot about if you've ever used PCs. Now later CGA cards like this one here from VTEC, which I've shown a whole bunch on the channel, they designed this card in such a way using these custom ASICs that there is no contention with the video memory and the CPU while it's refreshing the screen. This is the 64 kilobytes of RAM on this card. So even though this card is pretty much CGA compatible, it does not have the problem with snow. And if you run any applications that test for snow, like Jim Leonard's CGA compatibility suite, you won't get any on this card whatsoever. But with this card, I demonstrated in the last video, anytime you're doing the RAM access while you're in 80 columns mode, you're going to get this whole snow pattern. And depending on how much access there is, it can actually cover a lot of the screen. Now the 40 columns text mode and the graphics modes don't have the snow issue. It is really only a problem in the 80 column mode. So because of the snow on this stock CGA card, when IBM designed the BIOS routines to interface with this card, they designed in mitigations or strategies to minimize the snow because I guess they felt that that was kind of unsightly. Now, one of the two strategies that they employed is that anytime the BIOS routines go to update even one character in the video memory on the card, it actually waits for the blanking of the CRT. So you have to remember the beam is scanning across the CRT screen, but there's horizontal blanking intervals where the beam is turned off and then it moves across the screen to start the next scan line. And there's a vertical blanking interrupt as well, where it's at the bottom of the picture, it turns off the beam and it moves up to the top. If you update the RAM in those blanking intervals, you're not going to see the snow. There still is snow, but because the beam is currently turned off on the CRT, and if you do the update quickly enough, well then you're not going to see anything. Now the strategy of waiting for the blanking interval is fine if you're just updating one character. It just slows things down a little bit because the CPU actually has to wait for the beam to finish scanning the entire scan line before it can update the video memory. But if you're trying to scroll a screen, you have to update the entire memory address for the whole video page because remember, you're rewriting every single character and moving it up a line. So there's a lot of accesses that have to happen all at the same time. Well, because that can't really happen inside the horizontal blanking interval, it would just be way too slow for scrolling. So what IBM decided to do is use a feature of the 6845 CRTC to have an output that actually disables the entire video image while the scrolling is going on. So instead of seeing snow, you're just going to see a black image. That flicker that you get during scrolling is very obvious when you use the CGA card, and that was the design decision that IBM made, and I guess they felt that that was a better compromise than seeing the snow. So let's boot this card up so I can demonstrate this flashing that goes on that is built into the BIOS and DOS routines for scrolling and see about how we can get rid of that. Now, while the system boots up here, let's just talk about the fact that there are a couple different ways the video card is written to. One of them is BIOS routines. That's the system BIOS on the motherboard actually has some routines for updating the video memory on CGA card. And those are software-based interrupts. And DOS itself also has these same types of routines, but I think they're more capable, a little more functional than the ones in the BIOS, which are very, very basic. So with the system booted up, if we type directory here, oh, we're actually getting snow. That's really funny. Why are we getting snow? I think what's happening here is I have an ANSI.sys driver that's loaded in the config sys. And I remember when I installed it, I forgot the name of it, we'll look at it in a second, but I think it said that it was faster at updating the screen than the stock ANSI.sys that comes with DOS. And I have a feeling one of the things it does is essentially get rid of that waiting interval for doing the scrolling, which results in the snow that you see right there. So that's what you get on CGA when you do not blank the video output while you're doing that scroll routine, while you're updating every single character on the screen to move it up one line. Now, if we go to 40 columns mode with mode CO40, there we go, you'll notice that, well, once it starts scrolling, there's no flickering or snow at all. And that's because that CPU contention only happens in the 80 columns mode. Now, interesting is you notice here, even while this is scrolling, there's a little bit of snow as well. And I think that's because this ANSI.sys I'm using doesn't wait for the horizontal retrace before it just prints one character to the screen. This has a big effect of speeding up the entire display routine. So to see if this ANSI.sys is what was causing that snow, I rebooted the system, held down Shift, so nothing loaded now. And now when we type directory, there's that flashing I was talking about. And also notice there's no snow as it's just printing the directory as well. The ANSI.sys driver that I'm using is patching those software interrupts that print characters or do scrolling to eliminate that wait cycle, which actually speeds up the text output with the effect of creating snow only on these old original CGA cards. There are other more sophisticated strategies for updating the video memory in a much faster way, but also waiting for the vertical or horizontal refresh to happen to eliminate snow, but also get much faster video update rates. So the particular version of ANSI-sys that I'm using that seems to patch away those wait cycles that creates the snow on this card is Xansi.sys. Here's the README for Xansi, and it says here that the Zephyr ANSI driver is based on Daniel Cagle's excellent ANSI driver Nancy with an N. Xansi is faster than Nancy and takes up less disk and memory space. However, Xansi is slightly less powerful as it is missing non-standard character translation handler provided with Nancy. I guess it doesn't really matter because he says that nothing really uses that. And here we go, we have a little bit of benchmarks here. So I guess the stock ANSI.sys that comes with DOS, at least whatever version that they're testing here in the 80s, has some speed up routines for the character printing over like not having anything at all. Because it says here it's 18% faster than having no device driver. But if you use Xansi, it actually is 44.7% faster than having no device driver. So currently, because we're booted into DOS and I held down Shift, there's no device driver. So whatever the speed we're getting here is, the Xansi is potentially 44.7% faster. Although I'm running DOS 622, and maybe 622 has more optimized text printing routines for CGA over the older versions of DOS. Not 100% sure on that. But Thomas says that Xansi is still 32% faster than using ANSI, and it's even 8% faster than Nancy. So all these different ANSI drivers here with different speeds, but Xansi does have a noticeable speed increase when you use it on machines that are super slow like this. Having an ANSI device driver loaded does use up some memory though, and Xansi takes up a bit more space than the original DOS ANSI, but it's better than Nancy. Now, in case you're not familiar what the ANSI device driver does, besides, well, speeding up the display routines, at least ANSI, it also interprets VT100 style command codes in text files or programs or whatever to display them on the screen. So here's my PCJunior.ans file. This is an ANSI text file that has a bunch of control codes to move the cursor around and display colors and stuff like that. And if we try to display this right now, you're going to see that it's not really going to work properly because those control codes are not being interpreted by MS-DOS. It's just printing them out there. These are escape control codes that change colors and stuff like that. Now with the system rebooted with Xansi.sys loaded, of course we get snow, but if we type PCJunior.ans, it's going to interpret this properly and we get a little snow while it's drawn, but there it is all in full color. And that's because those ANSI control codes are now interpreted by that device driver. Now, I was chatting with Jim Leonard about this whole thing with the flashing and the snow and all that stuff, and he said that back in the 80s, because he was a big PC, XT, and CGA person, there were lots of programs out there that you could download that would patch those interrupt routines, that would eliminate the wait states, but it would also create snow, and that he used one, it was called Quick CRT. So a quick Google search took me to this archive.org program, which I think this is the same one. A program to increase the speed of DOS's screen BIOS. Not super descriptive, but it does say the date is 1993, which Jim thought was a bit too late compared to what he used to use, which was back in the 80s. Unzipping the file I just downloaded, there's a doc file here, and it looks like the date is 1993 on here, but that just could be a timestamp from when the files were copied. So here's the doc file that comes with Quick CRT, and yeah, it basically just says it's able to speed up screen I/O because it replaces the PC's slow BIOS video routine with new slick BIOS replacements. All programs that use BIOS or DOS to write characters to screen will be sped up automatically. It only works on the 80 by 25 character mode, but all other modes will not be sped up, but they'll still function properly. And that's because, like I said, the 40 column text mode doesn't have those wait states already because snow isn't a problem. This program uses up about 2K of RAM when loaded and is written entirely in assembly language, and it's invisible to your applications, just loads Quick CRT and your programs will run faster when they write to the screen. We have a few different command line options, /F, fast speed up. Doesn't really say what it does differently than the slow speed up option. Oh, it stops most of the snow. So it's funny because up here it doesn't really talk about the snow that this is going to cause on CGA. At least I don't see that. So /S option must have more optimized screen printing routines, but still does some amount of waiting for the horizontal or vertical refresh. And actually, look at this. You have a /T option that allows you to do a test pattern. So maybe we'll be able to get some benchmarks to actually see if Xansi has the same speed up routines as this program. So I'm using the PicoMem for disk emulation, and I've gone ahead and I copied the Speed CRT program onto this DOS 3.3 disk image here. So all we need to do is reboot here, and I'm going to push A to boot from this floppy disk. And actually, this may be a good test because now we're using DOS 3.3, which perhaps has slower routines. There it is, Quick CRT. So we do Quick CRT /T. That was that test pattern that it talked about. Okay, space to redraw the screen. Well, there's no snow or anything, but it kind of gives us an idea of at least how quickly it's drawing each line. And it was Quick CRT /F to do it with snow. So without snow suppression. Okay, so yeah, there we go. Quick CRT /T. I mean, that's a dramatic speed increase, isn't it? That might be much faster than that Xansi program, actually. Now that we look at it, I am actually quite frankly flabbergasted. We got a little bit of snow happening there, but the scrolling seems to be just as bad as with Xansi. But if we change to Quick CRT /S, it's reactivated but with snow suppression. Okay, so we still are getting the flashing when it's scrolling is happening. But let's see if we do /T. All right, so we still have speed up for general letters. I don't really see any snow. Yeah, it looks completely snow suppressed. But unfortunately, we're still getting the flashing. So I just ran the VI text editor and we're getting a black screen. And this is one of the things actually that I remember is a problem with some of these speed up utilities. This particular VI utility I use, which is ancient, doesn't seem to work with these speed up utilities. It just gives us this black screen. And I don't know why, so I'm gonna have to reboot the system. And what I was trying to do was I was gonna add the Xansi.sys, and their VI is working fine, right? So we'll just fix that and we'll try this again. I'm pretty sure that the way Xansi works does not screw up the VI text editor, but maybe it doesn't also create as quick scrolling as the other program does. I'm not sure, but I've tried other speed up utilities and they seem to screw up this VI text editor all the same. Free VI 1.9, copyright 1987, 1988 by Pseudonym. Pseudonym? That's funny. I don't know who actually wrote this because clearly that's not someone's real name. That's a pseudonym of some kind, but I don't know where I found this, but it's pretty cool. It's a DOS text editor that works on even the oldest versions of DOS. Anyways, let's go CRT /T. Notice it does not really speed up that text right there. Also, there's no snow happening. Very interesting. But obviously we get snow while we're scrolling and we don't get the flashing. Now I have this program called CDIR, or Color Directory, and notice when it scrolls, the screen still flashes. So that's pretty interesting. So I guess it's bypassing whatever patched routines Xansi installs. and it's just doing it on its own. Now, what if we do quick CRT while Xanthi is running? Is that going to give us the speed up that we so desire? CDIR. Nope, CDIR seems to be no snow and also flashing. And let's see if we get the speed up routines there. Yeah, we're definitely getting the speed up routines there. And that really is an unbelievable speed up compared to not having it running. Now we can deactivate the quick CRT program, and that's what we would obviously need to do if we were going to run the VI utility. Now we're still getting snow because Xanthi is still in place, but I think VI now works. And if we exit out of VI and we reactivate quick CRT, now when we run VI, we just get a black screen. Let's see if I can still exit. So I can exit, but notice things are a little bit corrupted for whatever reason. Let's try the slow mode of quick CRT. Clear the screen here. And we run VI, same thing. It just crashes. And look, we get a bit of corruption at the bottom there. And if we deactivate it, then VI is working. So I'm not sure how many programs exist out there that exhibit this particular issue. Now, if I were using MS-DOS back in the day, oh, look at that. There's still a bit of corruption there. Oh, that was just because it was left over. I think what VI is doing is it's using an alternate text page. And the reason why is when you run VI, and when we exit the program, notice it restores what was on screen perfectly. And I bet you that's using one of the alternate text pages in the CGA buffer because it supports 4 text pages. And I think that's what breaks when using those speed up utilities. I think it uses those extra buffers to do some kind of double buffering or something like that to speed up the text routines. That's my assumption, at least. Okay, so you've seen everything on the CGA card that happens with the stock card, with the flashing and the snow and stuff like that. Now back to this VTEC card. So they re-engineered the way the memory access works so you don't get any snow. But the thing is, if you have a card like this that has no snow issues, typically when you do a DIR command, you're still going to get that flashing. And that's because the IBM PC BIOS can't tell the difference between a real CGA card and this re-engineered CGA card. And that flashing routine is actually stored in the BIOS code itself, or maybe in the DOS interrupt calls itself. And therefore you get flashing. Now the thing is about this VTEC card, and if we actually pop this in and demonstrate, not only does it not show any snow, it doesn't have any of the flashing. Now what it does do is notice when we turn on the system, you saw that like weird blinking that happens? That doesn't happen on the original card. And I'm going to talk about why I think that is. I'm not 100% confirmed why, but I think I know why. Okay, so here we are booted up into DOS 3.3. It looks pretty quick the way it works. You know, there's no snow, there's no flashing, none of that stuff is happening. Now that Xanthi.sys is running right now, but we can run quickcrt/f, and now if we run quickcrt/t, there's that fast routine, and there's no snow, nothing bad is happening at all. But if we rename configsys to remove the Xanthi and reboot the system, the question is, now that we're running bone stock DOS with the bone stock DOS display interrupts and the BIOS interrupts, why is there no flashing when it scrolls? That doesn't really make sense. Well, it didn't until I thought about it a little bit. I've made my way over to the IBM CGA schematics for the original CGA card, and right here is the 6845 chip. Now right there, pin 18, is a signal called display enable. And on the CGA card, there are several control registers for configuring the card, changing graphics modes, doing stuff like that. Well, there's a mode control register, and right here, bit number 3, a 1 enables the video signal, and the video signal is disabled when changing modes. So I hit up Jim again and I asked about this bit 3, and he definitely confirmed that what happens with these stock scrolling routines is when they go to scroll the screen to avoid the snow, the routine will actually toggle that bit 3 off, which has the effect of disabling or blanking the entire screen while the scrolling is happening. And then when it's done, it re-enables that pin, which turns the screen back on. So very specifically, it's that bit toggling which has the effect of blanking the screen. Now, as I mentioned at the beginning of this video, there were compromises that had to be made because you are either going to get snow during scrolling or you were going to get a blank screen. And I guess IBM decided that a blank screen was better than snow, and lots of people might totally agree with that. But me personally, I don't like that. I feel that the blanking is actually kind of unsightly, and I would just rather have a little bit of snow that happens, or it's actually going to be a lot of snow, as we've seen with these speed up utilities. So that got me thinking, can I just hardware mod this card to disable that flashing altogether? Basically disable the output of this CRTC pin 18. Therefore, the screen is just always going to be on all the time. I think it will be pretty easy, actually. And that also made me realize that if I turn off the system here, The reason why this VTEC card does not flash, even with the stock routines, is because it just ignores that bit 3 entirely. Or if that signal is available on these ASICs, it's not actually hooked up in a way that would disable the outputs. There are several jumpers on here that do all sorts of things, and maybe one of those jumpers actually re-enables that feature. I'm not totally sure. But definitely this card is just ignoring that bit 3 entirely. And because it doesn't have any snow, there's no ugly artifacts, and that's actually a really good compromise. Now, remember when I turn on the computer with this card in there, you see that kind of weird flashing, corrupted garbage? When you have a real CRT hooked up to the screen, you also get kind of a totally unsynchronized picture until the BIOS initialized the video card. And that does not happen on the CGA card here because I think that bit starts out as 0 low, which has the effect of disabling the video output. And only once the BIOS initializes the video card does it bring bit 3 high, which turns on the picture. So my hunch is with a hardware mod on this, that will have the effect of making it work just like the VTEC card, where it will cause that garbage when you first turn on the computer, but it will also disable the ability for the BIOS or the DOS routines to even flash the screen during scrolling. So back on the schematics, it'll be easy to disable this. Essentially, display enable comes out of there, goes into this gate here at U20, and then that comes out and goes to a couple chips. All we need to do is break the input to pin 3 on this gate and tie it to 5 volts through a resistor. And that means it's always going to be enabled all the time. And I should be able to do it because I've looked at some of the traces on this board in a way that could be pretty easy to undo and restore this board back to its stock configuration. Okay, so the mods are complete. I've gone ahead and installed a pin right there and right there so I can connect the jumper wire. And then I put a little tiny break in the trace right there. And I can actually just bodge over that with a little blob of solder if I want to restore this back to the way it was. So if I just connect a DuPont lead between these 2 pins, that will have the effect of, keeping this thing 100% stock. Or I could restore this. I also went and installed a couple other mods which I haven't really talked about yet, but I put a 2-pin block right there. This is P3, which is actually a jumper that I don't know if this is even installed on any of the actual IBM CGA cards, but the footprint is there. And if you install a jumper on here, that has the effect of turning on the 1 character wide font. Normally you're running with a 2 character wide font. Well, putting a jumper there enables that thinner font. Now I did go ahead and I installed an extra pin right here as well. I didn't cut any other traces, but I just installed that. And that is for something I want to try later. But I've never actually tried this jumper here to see if this will really work in 1 pixel wide font. But first off, let's go back to this display enable on the flashing and see what happens right now with this signal cut. I actually went ahead and installed a wire on there just so we can make sure the card is still working properly when I turn on the power. So let's see what happens here. Okay, good. We have a picture. Didn't want to have broken this thing. Okay, booted up into DOS. If I unplug this wire, I assume we're just going to lose the picture altogether. No. That's weird. Huh. Maybe I cut the wrong trace. Yeah, because this is weird. If I type dir and I unplug this, it stops updating, and obviously things look kind of screwed up as well. And as soon as I plug it in, the scrolling resumes. So I think I cut the wrong trace there. I don't think that was the right thing to cut. It's funny how it makes the system work. It doesn't crash anything. All right, I figured out what's going on. I was a bit of a bonehead there. The display enable signal has more to do with the borders, like the overscan area of the picture. Essentially, the CRTC turns off the image for the border areas, and then it turns it back on when the electron beam gets back into the active area. And the reason why it stopped scrolling when we saw text in the overscan area when I disconnected that wire, because that's the signal that those interrupt routines in the BIOS and DOS wait for, so that it can update the screen memory when the beam is turned off and you don't have any snow. So it just waited indefinitely there until I reconnected that signal. And one thing that I should have done, and I didn't do before, is I hooked up the oscilloscope to the output of that signal, and I could see that it was toggling every single scan line, and it had nothing to do with the flashing during scrolling. So I started to look around to see what is generating that bit 3, which turns off the image. I was assuming it was coming from the CRTC, but I was completely wrong. It's actually coming from this chip here, U40, which is an LS174. And it turns out that this is the signal right here, Q4, pin 10. If we scroll over here, video enable. And this goes over to sheet 5. And here's the video enable signal there on sheet 5. And that makes its way over to this gate right here. And the output of that gate, pin 3, is some clear SW signal. That goes off to the rest of the card. But Let's put the oscilloscope on that signal and see exactly what it's doing when we scroll. All right, so I have this clip on U13, which is the input to the gate for that video enable signal, and I'm on pin 2, which is the signal, and currently this is waiting for it to go low. Now, if we turn on the system, we're not going to see anything here, I guess. And there we go, we got a couple downward flashes. All right, so the system is now booted into MS-DOS. I don't have any of those drivers loaded, and currently this is high, which is why we're not seeing an update. But when I hit enter and it flashes the screen, we should get an update on here. There it is. Right there. So every time I hit enter, we get this signal going low, and that's what's blanking the screen. So that right there is what I should have cut, not that other signal. And this will allow us to manually control whether the video is enabled or not. Forcing that signal that goes in the gate up to 5 volts all the time will result in the image never being able to be turned off by software. Okay, here's the mod I did. So that's the pin, that's the input for the display enable signal, and I cut the trace right there. I used a little engraving tool. And then I put a 4.7K resistor over here to 5 volts, and that should pull pin 2 up all the time. Let's see if this works. All right, here we go. All right, that's what I would expect, some garbage until the card initializes. Ah, and some snow. I love it. All right, yeah, totally normal. Like when the card is uninitialized, normally the display is blanked. And what happens is it's not blanked now because it's always enabled. And therefore, oh, I got to hit A for booting off the floppy. There we go. All right, here we go. So the bone stock system, will we have flashing? No, we will not. So there you go. If you want to do a hardware mod to permanently disable that flashing and you are okay putting up with some snow, then there you go. Of course, that will only happen during scrolling. During normal text operation like that, you do not have any issues. And that's because the BIOS routines only disable the video during the scrolling and not during the normal screen update. I don't know, I just kind of like it. I think it's pretty cool. Now, this doesn't speed up anything whatsoever, right? Because of course, DOS is still waiting for that vertical refresh and stuff to happen. You know what? I just had a thought. We might be able to do another trick here to trick the system into always thinking it's in vertical refresh. That signal that I cut here, and when we unplugged the wire, you know, we weren't getting any screen updates. Well, let's go figure out where that signal goes. It must go to a couple different chips. And maybe if we cut the trace at the right point and we ground the signal going into whatever that chip is, wherever it is on the board here, then DOS will always think there's horizontal or vertical refresh and it's safe to draw, which would speed things up. Now that might break other things because maybe certain pieces of software wait for that. Oh, by the way, the 2 pins that I installed right here for the character set, those do work. Look at that. There we go. We have the thin font, and you just take that jumper off, and now you have the thick font. Unfortunately, there is no way to software control this, at least not normally, but maybe that's the mod that I was thinking of doing. So remember how I installed an extra pin over here? The reason why I did that is this pin is connected to the flashing circuit. So when the attribute bit is set for flashing text, this pin changes. Well, this thing here, when you put a jumper on it, basically grounds this pin on the left. The pin on the left is pulled up to 5 volts, and that goes to the address line on the ROM chip. Well, when you ground that, basically you get the thin font. So if we connect a wire from there to the flashing output, what I think that should do is anytime the system is displaying normal text, it should use the thin font. But when it's flashing, it should display the text in the double thick font, so like bold almost. Now, before I turn this on, my thought is that the screen should come up with a thin font, and then if we go into a program that displays flashing text, then that text should be flashing, but also be double wide. Now, if I cut a trace on this, we could disable the flashing, and that would change the attribute bit that changes flashing to not flashing text into double wide text or single wide text. Let's turn this on. That's normal, everyone. Don't worry about that. There we go. We have single wide text, just like I thought. And I think this is the test mode that's going to show flashing text. Let's see what happens. Here we go. Yes, there it is. Okay, so the Y is single wide, but the rest of it isn't double wide. Yes, this is what I thought would happen. Now, I'm not sure why the Y in your is not double wide, but that's an idiosyncrasy there. That's pretty funny. But I know that Check It has a couple modes here that will also show the flashing text. So let's just see how those look. This is hilarious, I think. All right, and there it is. So that's really interesting and curious how the blinking only affects the second character and not the first. Now it's possible there's a delay actually, and even the character after, like where it says text, if there were another letter there, it's possible that that would also be double wide font. But we can't tell because all these tests don't print any extra characters there. I love it. This is just so silly, this kind of stuff, but I feel that's kind of a cool little mod there, actually. Now, in order for us to invert the entire effect, where everything was double wide font except for the flashing text, we would need to invert that with a gate. And I don't know if there's any extra gates on this board. We need to install like a little extra chip on there or something. So back on the schematics, if we look at pin 2 right here, attribute 7, that's the bit that enables flashing text or not. And it comes out right here and it goes down to this gate. I'm pretty sure I'm picking up the signal right here on pin 9. That signal there, pin 9, is mixed with this enable blink signal, which I think is actually one of the registers you can set, that you can turn off the blinking and enable more colors of text by using that attribute in a different way. So I think that's what that is. And then the output of this gate goes into here, into this 153. And that must be what exactly toggles the flashing text, because there's the video output itself, the RGBI. So the only reason why I think we're getting the first character not double width is that the address line signals that go into the character generator must be delayed by a certain number of pixels or something like that. There must be a delay circuit in the board somewhere. And I wouldn't be surprised if definitely the character after the flashing text would also be double wide. So I guess this character set font mod isn't, well, the best thing in the world, but I kind of like this mod nonetheless. I actually prefer the single wide font. The single wide font doesn't look as good on low res CRTs, especially if you're using the composite video. So that's probably why IBM went with a double wide font, just to accommodate all possible CRTs. But I think this is a neat compromise, and it's kind of cool to see the blinking text actually have that bold font as well be used. All right, let's go back to that display enable thing I was talking about. So display enable makes its way from the 6845 onto this sheet here. It goes through that gate. That's the signal that I cut, the input to this gate here. Now this splits off and it goes into this LS174, which is a register, I think, and the output of this is some delay lines. So I don't know if that's what's being monitored. Let's follow the other output here. This display enable signal here goes to sheet 2. All right, there it is, display enable. It goes into this LS244. And what does this go to? This actually goes to data lines. Yes, okay. If we look at the enable pin to this LS244, look at that, status select. So without a doubt, there's something set when you're trying to read something out of the CGA card, and this actually will connect those signals, which besides the display enable is some light pen stuff and vertical sync, and that allows it to be read by the computer. So I think all we need to do is cut this connection here that goes into pin 17 on this 244 and keep this grounded all the time, and that will trick DOS and the BIOS call into thinking that the vertical or horizontal retrace is happening, and it won't wait to print characters. It will create even more snow for even printing normal characters on the screen, but it should actually create that speed up that we're doing in software with those utilities, but it will be all the time. So let me go try to do that mod and let's see what happens. Okay, here's the 244, it's pin 4. That is the input for that register or that status bit. And it's this trace right here. So I just cut through there. And on the back side, I permanently grounded the input to that pin right to ground here. And it's okay, you don't need to use a resistor for this kind of thing. Grounding inputs to these types of these chips is totally fine. So I have no idea if this is actually going to work or not. This might result in some kind of weird artifact as well. So I may need to undo that. I don't think this should have any effect on the border region or the overscan and stuff. Like when I made that first mod that didn't work. I think this should just cause it to speed up and create some more snow. This is very similar, if this works, to the fast vid or the speed up hacks for the original Commodore PET. It's just doing it in a way that doesn't create a bus conflict and that doesn't destroy things. Okay, so we have a little bit of an issue here. It initialized the card, but we're not getting any actual updates here. I think what we're seeing here is purely a software issue too. This is not a hardware problem. This is just the way the software is written is expecting that status register to do something on that particular bit, and now it doesn't. It's just grounded all the time. So it actually thinks that the video is never enabled. It's probably why it's just sitting here waiting now. Okay, I have a thought. The LS244, besides the display enable input, has a VSync input, and I just checked it with the oscilloscope and it goes high 60 times a second. What if I connect that line up to the display enable input on the status register, which maybe will get that BIOS routine that waits for that signal to start running, but most of the time it's going to think that the video is in the border region, which means it doesn't have to wait for any kind of snow issues. Let's try that. Okay, there it is. The input for display enable is now just connected up to that VSync delay signal. Let's try that. I'm just going to add here that I know all of this is absolutely silly and completely pointless. Oh, it's running, but it's so slow now. That had the opposite effect of what I thought it was going to do. I thought it was going to speed it up, but it actually is really, really slow now. It's only updating the characters once per second. Oh, that's so hilarious. Now, the funny thing is, if we boot up here, we wait a really long time here, and we boot the floppy disk, and we run that speed up utility, it's actually going to make it run really fast. Oh, this is super funny. Look at this, really. Scrolling is quick. So quick CRT/F, as soon as this gets installed. Yeah, there we go. It's fast now. CRT/T. There's that fast update speed. Because it's no longer waiting for that register anymore. But as soon as we disable it, we're like running at what, like 2400 baud here or something like that, or even slower. Oh, that's really hilarious. All right, so this speed up mod, at least here, doesn't initially work. What can I hook this line up to just make it go super fast? Ooh, what about the 14 megahertz clock signal on the board? Maybe that'll make it go super duper fast. Yes, let's do that. That's the last mod I'm gonna do before I just restore this signal back to its original. All right, it's connected to the 14 megahertz there. It's just on a nearby chip. I have no idea what this is gonna do. It might work, it might not work, I don't know. Who knows? Let's see. No, it's too fast. Okay, let's just take a look at what that signal looks like with the oscilloscope now. All right, definitely have it on 14 megahertz. There it is, the signal going into it, 14.3 megahertz. Too fast, I guess. That doesn't work. I'm gonna look around for slower clock speed than 14 megahertz and see if I can find one that actually works. Alrighty, I got it. I just hooked it up to an adjacent pin that was like 3.47 megahertz, whatever the NTSC clock is. And instead of 14 megahertz, it freaking works. And it's definitely faster than stock. It's not as fast as quick CRT is, but that is way quicker. I noticed, I mean, we're getting snow now, but yeah. And incidentally, I'm booted up into DOS 3.3, and there are no like utilities or anything on here loaded to speed it up. This is bone stock. And sure, there's snow, but it's working. It absolutely is working. And hitting Control-Delete, we get some snow and stuff in here. And let's go to the setup of PicoDOS. Yeah, same thing, a little bit of snow here, because I'm assuming it was probably waiting for that signal as well. But I am guessing that 3.5 megahertz is actually a lot faster than the, what, 15 kilohertz or so that was happening on that signal originally, because that is the actual horizontal refresh rate, 15.6 kilohertz. So we're definitely having a speed up because it's not going to have to wait. It's going to still have to wait a little bit for that 3.57 megahertz. But yeah, it's not going to wait as long. This is so cool. Now, I was hoping that the 14 megahertz one worked, because that would be like the bare minimum amount of waiting for any kind of, thing to happen. But it's really snowy even here in Check-It. I kind of love it. Okay, so let's go over the mods one by one, just so you can replicate all of these mods yourself. So the first mod is the character or flashing mod. So first thing you need to do is install the little 2-pin header right there at P3, which will allow you to put a jumper on there, whether you want to actually have thin characters or thick characters. The other thing you need to do is install a pin header there right next to the U92 marking. You can see where it is on the board there. You just have to clear that via out and install that pin header. Then all you need to do to enable that extra character set for the flashing is just install a jumper wire between those two wires. If I take this off, this will just be double wide font all the time. If I put a jumper on there, it'll be a single wide all the time. So nothing was cut to do this particular mod. The next mod disables the flashing when you type dir in exchange for snow. So what you have to do is you have to cut through the trace right there. So use a little tool or something to cut that. And then I installed a 4.7K resistor between that pin and that pin, which is 5 volts. I'm basically pulling this up to 5 volts all the time. That prevents that register from disabling the video while the scrolling is happening. Now the actual chip we installed that resistor onto the back of is U13. So if you just want to make sure you're in the right spot, you look for U13 and then you go to the back side and you install the resistor and cut that trace. If I restore this trace here and I even leave this resistor in place, it'll be fine actually, to be honest. That will restore the original functionality. Now you could try to put a little piece of metal across there to rebodge, or maybe even a blob of solder, or you just have to install a bodge wire from here to wherever this goes to, right there, that via, which I have in green. So put a wire from there to there, and that will restore the functionality. Ignore this bodge wire right here. That was just to fix the original mistake that I made with the mod, so you don't need to do that. And then the final mod we just did that does the speed up for the character printing routine is going from pin 17 on the LS244 here and goes down to here on this pin. So look for the vias right here that are like that. You go to that pin, that is that 3.57 megahertz that I'm picking up. Before you do that though, and this is on U24, the LS244, you have to cut the trace that is normally feeding that pin on pin 17. And that is that right there. So I just cut through there, and now that disconnects whatever pin 17 was originally connected to. To reconnect this, all you have to do is either put a little blob of solder on there, and if you can't do that, then you need to put a wire from pin 17 on this chip. And I think that was something over here on like this chip or this chip. I can't remember exactly which one it is, but you just have to tone it out from the left side of this little hole I made here over to the appropriate pin there. A bodge wire will just restore the original functionality. Now, as for the compatibility of these mods and to what this breaks, I don't really know. I have a feeling if we put this thing back in the computer, it's probably gonna have a negative effect on Area5150. It probably uses that signal to do some of its tricks. Let's see what happens. All right, so here we go. Let's run Area5150. Ooh, this might have an effect also on some of the graphics it does, because it might be expecting to have the double wide font, but we'll find out in just a moment. All right, it's not even loading at all. It's just hanging here. And I bet you this is the mod on the 244. That 3 megahertz clock that I hooked up there, it's just not liking that. It's probably looking for that display enable signal to be going into that 244. So I'm gonna undo that mod that I did here on the 244, and hopefully that makes Area5150 run again. All right, the mod's been reversed. As you can see, the system is booting. Oh, I don't want to boot into with the config sys. Okay, good, I made it. And obviously, now we don't have any snow except while scrolling. So pin 17 on the 244 goes to U20 on pin 4. That's originally how it was hooked up. So I just put a little bodge wire back on there, and now we're all good. Let's see if the demo works though. Okay, yeah, I was like, oh no, it's still not working. Okay, so it works. So there we go. You definitely need that mod. Oh, interesting. This is looking a little funky here, and I think this is all because of my character mod here with the font. We can try by taking this jumper off. Yep, there we go. So that's interesting. that causes that problem. And that's all due to the trickery that this demo is doing with this thing. Let's restore this again to the mod. Let's see. Okay, there we go. It still looks okay. So now it has a little bit of noise around some of the letters and stuff like that. So obviously, if you're going to run this demo, you need to remove that jumper and just have it running with the standard font. Interesting, there's a little bit of snow there. Well, that's obviously because it's turning off the display, I guess, for a moment, and that doesn't work now that I did that hardware mod. So there's a little glitches here and there. I'm assuming it's due to the font thing. Some of it's due to the font thing, and some of it is due to the display enable that I've just bypassed. Like this part here looks fine, I think. Let's take the jumper off. I don't really notice a difference there. Let's put the jumper back on. Yeah, I think it's basically the same. A little bit of corruption there, and if I unplug the jumper, oh well, I was too slow there. That would go away. How about on this part here? This uses the text mode for sure. That looks totally fine. Yeah, I have the jumper on right now, so we're using mostly the skinny font. Looks completely, yeah, no issues whatsoever. All right, so there we go. There's a couple mods on the CGA card. All of them are pretty stupid. Honestly, the one that does the speed up in exchange for some snow is kind of cool. I like that one. As far as the one that disables the flashing, that doesn't cause any kind of speed up. It just gets rid of the flashing and then you get some snow. So whether you want that or not, I don't know. The mod with this orange wire that gives us the bold font with the flashing, it's kind of silly, but there you go. Obviously, it's as simple as just removing this jumper wire and then the card is back to stock. Maybe in the early 80s, when this card was out, people would have liked some of these mods, and perhaps some of these mods were already documented. I know everything I did here was completely useless, but it was still a fun exercise just to kind of see what you could do with a card like this. And back in the day, you were armed with those schematics. Those were freely available, and these mods were pretty simple to do, and anyone could have done them. Maybe people would have cringed at cutting a trace here or there because, you know, this card is worth hundreds and hundreds of dollars and you're causing damage to it. But there's no damage. We just put a couple bodge wires on the back and it's back to fully operational again, just as good as it was before I started. And remember, this card was found in the trash. It was about to be scrapped anyways. So the fact is that I made these mods and stuff to the board. Does it really matter? No. This is all period correct stuff that someone might have done back in the day, so I think it's totally appropriate. Let me know what you think about what I did here. If you hate it, you think I've ruined this card, definitely put a comment down below. If there are other mods we could do to this, like a speed up mod over here to the LS244 that could make it go faster, maybe using a clock signal that's even faster than that 3 megahertz that I used, let me know. Take a look at the schematics and see what you think about this whole thing. I'd love to know if you back in the day had one of these cards and did some of these hardware mods as well. That would be pretty cool. Or did everyone just simply rely on the software mods like I showed at the beginning of the video, which obviously didn't involve any hardware changes to your card, but could only work if you're able to use those utilities. So yeah, there we go. This video has gone on for actually quite a lot longer than I thought it was. I thought I'd do a really quick video, and I think this is going to be a long one. So if you liked it, thumbs up. If you didn't, you know what to do. Huge thanks to my patrons. Their names are scrolling beside the screen over here. They make it possible I do this full time. And I think that's going to be that. Oh yeah, don't forget I'm going to be at some VCFs coming up. I'll put a link in the description below if you want to check those out. And I think that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.